All right, let me check the connection. Cool. Okay, so welcome everyone again to another episode of Cloud Development course, or like if you're watching it in the future, might be called something different. It might be AWS Practitioner, it might be Node.js in AWS. So whatever the name is, I welcome you. And today we're going to be going through a bunch of stuff that's kind of piled up over the last 2 weeks. First of all, we're going to have a look at the last two modules, which is async microservice communication, and then authorization and different ways to do that. And if we have time, we will cover containerization, just the basics with some spoilers for the home task. And just a quick word to regarding the structure of the course. We had a small update. We have now an architecture PDF that you can check out that has everything you need to know about the whole um, course home task. It could be accessed directly from the main branch and the main code page, or if you're going through the module itself and accessing the task or the assignment, you will have a link from there just as a small reference. So this is a new section in each task. And this is basically just for your convenience if you want to check out the focus of the architecture of this task in particular. So let's check out the architecture itself. So this is a PDF of the entirety of what we're building. So quite a few services, and we went through most of them already at this point in this current run of the program. However, um, this thing is huge enough for you to be confused in each and every task. And since we're going through tasks one by one, um, we also have a task focus drop down that gives you an idea of where you're going to be building in the scope of this particular task. So this is like one of the major changes to the program. And let's go back to the main topic. So which is like 6 and 7 module. 6 module was covering SQS and SNS, which are AWS way of providing async microservice communication. The goal was to learn about their services and in general what problem are we solving with async microservice communication, and how does AWS kind of helps us with the whole thing. And then also, how do we integrate that with what we already know? So with a Lambda service, with an S3 bucket. Um, so a very interesting topic and very important one, I'd say. One of the most important in this series. And if we're talking about asynchronous microservices communication, you always need to remember about synchronous versus asynchronous. And what do we mean when we say asynchronous and synchronous operation versus asynchronous and synchronous communication? So these are two different things. Some of you who are coming from JavaScript background or we're using JavaScript in this course might be thinking, hey, that's pretty easy. That's taking something like 1 plus 2, be it a synchronous operation, and something like promise, and working with promise or fetch something using fetch API, be it a an asynchronous operation. Yeah, that's correct, because essentially we're waiting for our synchronous operation to complete before we proceed to the next one, when in case of the asynchronous operation, we're not waiting for that to happen. We're kind of notified when that happens with various different means, like promises, for example. Same with synchronous communication. In a typical environment, so let's take a look at our focus or on our architecture. In a typical environment, you are usually making requests and expecting some results. So our main product service, for example, has an API gateway where we make requests to that API gateway with an API gate link, then to a particular endpoint, and that request is getting transferred to or triggers a Lambda function. It does something useful, and then it responds back to us. The whole process is kind of blocked in terms of like I am making a request and then I'm waiting for the response to happen. If the response doesn't come, I am getting a timeout error, which is not the best case. If you think about that in terms of networking, that's saying like and all basics of HTTP. What happens technically is I'm opening a connection and I keeping that connection alive based on some timeout. And that connection is essentially stored somewhere. So the server knows about that connection. It keeps it in memory. You, the client, know about that connection. So you can imagine like millions and millions of users at the same time using your service, opening that connection, not an ideal situation. It puts a strain on the connection point, which is an API gateway. It puts a strain at any prior client services if they're using one to make that request. So yeah, that's basics of ACE or synchronous communication. Ideally, we want to have something like a synchronous operation in JavaScript, like hey, an event-based system. I request something, and then at some point I am notified whether that something has complete. And that's exactly what we're doing or exploring in the task 6, which is we're creating a couple of functions um, that respond to some events, and they make those events themselves. And that whole thing is highly scalable, highly available because send an event or to receive an event to do something with it is finite time and it's easily controlled in various different ways. So, and regarding that, I will be doing some demo in just a bit. Um, let's just take a look at our next section. So hopefully at this point you're already familiar with this set of services like AWS SNS and AWS SQS. You're familiar with the differences because some people are kind of fuzzy in terms of like, why do I have two instead of just one? Um, so yeah, these are key focus points for you. Um, Another key focus point is understanding of you can make requests in synchronous fashion. So a synchronous communication would be established where you actually wait for the response, and you can make same requests with asynchronous kind of communication. Um, and that's where you don't wait for something to happen. You either don't care or you're expecting that some other system will notify you about the result. This is a key point and making the whole thing as highly available and as highly scalable and easily scalable as possible. Okay, so now let's have a look at the task 7 in module 7 to kind of see where that fits in with the whole thing. So within module 7, we kind of talked through and made sure that everyone is in the same page regarding authorization and authentication. Um, we are using a bunch of services that allow us to establish some identity or provide access and check for that access for various different points in our system. Mainly, we're focusing on AWS Lambda being used as that checker of authorization or authentication when accessing an API gateway. So this task is all about um, covering your one of your API endpoints with authentication slash authorization requirements. And then optionally, we can have an entirety of our web covered with AWS Cognito so that only authorized people are able to make requests from the actual application, so from front end. Just a bunch of topics that I just mentioned are covered in this section. The key takeaway from this section is that understanding of the differences in processes and reasoning that we're choosing AWS Lambda as one authorization technique and an AWS Cognito as the other. So you need to be comfortable with an idea of they have different use cases. You need to be comfortable saying AWS Lambda custom authorizer is used because this is an admin panel, for example. We don't need to have millions of admins. That's why it's easy to handle that with AWS Lambda. And compare that to AWS Cognito as a specific service or service that was specifically designed by AWS to handle those millions of users, store their information, provide that level of authorization authentication to your downstream services. Um, yeah, and doing that in AWS Lambda as a custom authorizer would be just too kind of extreme in terms of complexity, and it's not needed anymore. So be comfortable with these terms. I also want to point out that with AWS Lambda custom authorizers, you don't actually need to store any information. You can use something like a stateless authorization authentication tools like JWT. You don't need to store sessions per se. Um, and with AWS Cognito, you don't need to provide any storage to store those millions and millions of users because it comes built in with user pools and identity pools being slightly different. So if you were to go to the optional tasks, you would be familiar with AWS Cognito. But let's just check if we are on the same page in terms of the task requirements. So again, with our entire architecture being like this, we would like to cover with authentication and authorization using a custom authorizer, one of the import service endpoints like import product files. So in order for people to import stuff in a quick and easy way, we want to have admins have that access. They provide their credentials. Those credentials are checked by basic authorizer when accessing the API gateway for import service. So, and that's why we can store even in the environment variables any information for those admins. That would be completely private in terms of the users and public would not see that information. So it's like a simple and easy way for us to provide that admin-like feel at the same time keeping at least some level of security for our import service. For API gateway that is hitting like various different services at the client level, so product service, optional task was to have a Cognito, but that's not the main point and the main focus. So let's check the task focus. The task focus for this task in particular is just these two guys. So hopefully you were able to complete all the tasks. Yeah, again, if you have any questions, be sure to ask them either like joining one of the Q&A sessions or directly in the um, Discord channel. But yep, That's exactly what we were doing. We are creating a separate service, or separate service, like in a microservice architecture that is handled separately with its own infrastructure within serverless YAML file. Now we have like three services that do different things. That service, authorization service, just by looking at this picture, provides a link or is somehow linked to import service. So we have just a bit more tangled services and coupled services, but that's all right. They are managed separately. We will be potentially be able to version them if we need to, and then create Lambda that does that dirty work, and it does that with a base 64 um, coding or encoding. So, and this is exactly why we want to have just like a known plain text password, for example, stored in the basic authorizer environment variable, just as one of the less secure options, but still possible to provide that basic authorization ability. So yeah, we are storing it as an environment variable. And yeah, that's it. There's just a couple of lines for you to change in the import statement or import service to provide that authorization capabilities. Um, and yeah, just check if everything works for you. The token itself, when talking about storing it on the front end, once you're kind of authorized through this flow, it should be stored in a local storage. Again, that's from the point of view of your browser. It's just a bunch of lines, not really um, readable. From the security perspective, that's not an ideal. A potential security improvement would be to have not like a base 64 encryption, but instead provide I don't know, some hashing with some salting or like official JWT stuff, and use that as basic authorization token. So the exact way that you're handling stuff inside of your authorization token is up to you. Essentially, if you want to up the security, but the task was just requiring you to use the base 64 encryption, which is like, yeah, less than ideal, but still. Um, and yeah, the storage, local storage would be persistent. So once user changes the link or closes that link and opens the tab again, the local storage will still be populated with the authorization token. Again, a potential improvement to this approach would be to use session storage. Um, and if you want to use session storage, the more ideal way of approaching this authorization would be again to switch to JWT because they are stateless, and that's what we are using with the session storage. So that was it. Now, let me just check if I have any questions. Okay, cool. I don't have any questions, so that means we have some time to have a live demonstration of the whole process. Hopefully, that would be a way for us as a program creators to help you go through any issues you might have if you were not able to finish the task in time, or if you're not able to finish the task as is ideal situation. So let's focus on our demos. All right, so let's start with the first task. Um, task 6. Let's check the task itself. It basically says that we need to have a bunch of Lambda functions, or in our case, just one catalog batch process Lambda function. That catalog batch process function listens to a queue, and then we have um, at some point a SNS topic. So we need to cover the communication between Lambda and these two. That's exactly what we're going to do. We're using the same examples repository that is officially maintained by serverless framework. So it's official serverless examples. Um, Let me check. Okay, cool. So, and we need to focus on our first example, and that being, yeah, SQS. Let's go with SQS TypeScript. So let's have a look at what we have in the example. As usual, we have just a bunch of lines. Let's just separate them so that we see it clearly. Services, providing us the name of the service that's going to be deployed. In serverless framework case, that would be a name of our stack and a cloud formation. We also have some plugins, and that's basically just to provide our way for us to build our artifacts before pushing it down to the Lambda itself. The provider contains just confirmation of the actual runtime as well as an IAM rule. And since it's inside of a provider, I am confident enough in saying that if I have a bunch of function in a function section, those both functions would have a separate rule that will be able to do stuff. If I were to go with a best practices in IAM, I would actually be trying to provide an IAM rule directly to the function itself, and there are ways to do that with serverless framework. Just a side note, if we have it in provider, that's basically allowing all the functions to use this rule. Okay, cool. And then, yeah, the function section, we have two functions, both doing something. So sender, I assume, would be sending an event using this SQS send API call. And then the receiver would be actually listening to, um, okay, yeah, vice versa, actually. Yeah. Um, Sender would actually be listening to the API call and be the one who's constructing. Oh yeah, that's okay. Constructing the message using this API call, so that's correct in the first case, and then receiver would be actually listening to events, automatically becoming a SQS subscriber to that event or one of the consumers, SQS consumers, and it will exercise the the subscription to a receiver queue. So if we have that the receiver queue with the intrinsic function get attributes REN, I assume at this point this receiver queue should be created, and since it's a serverless thing, we can have a separate resource created for us, and as simply as just typing some CloudFormation code directly into our serverless YAML, we are able to do that. So let's see. So it's AWS Node TypeScript SQS standard. So let's go there. AWS Node TypeScript SQS standard. Okay, so we're inside of this folder, and I assume that these functions, let's just double check, they are using handler.sender and handler.receiver. So these two functions, and they are defined in the folder SQS. They're both using TypeScript, so that's cool. We also have TypeScript configuration, and we also installed a Webpack config. And inside of that Webpack config, we're saying that, hey, this Webpack config needs to be managing TypeScript, and because of that, we need to have a separate loader for that. So in order for Webpack to use the loader, we need to install that. So I assume the package JSON would be installing that. Yes, we are installing it. So the first thing to do would be, yeah, let me just use the latest, or the one that I consider one of the latest versions of Node to do that. So I'm using NVM Node Version Manager to, to choose another version, and then I'm going to install npm packages. And while it's doing so, let's explore further. So a sender function, since we know from the looks of our serverless YAML and from what we expect there, it should be triggered by events from API gateway. So this section would be creating an API gateway for us for this post method and a pass sender, so /sender. With HTTP API, I assume, and all the rest, if I'm not mistaken, from the serverless framework. And then, so we are going to receive API gateway events. That's why we have this API gateway proxy type, because it will allow us to use a correct event and a correct context. And also, let's just have a look. We don't have any wrappers around this function, so I assume we are returning it in a correct format for API gateway. So this is expected from API gateway itself. Okay, cool. And the main body of our function is doing nothing more than just checking the body, and then to have that content to send, otherwise throwing an error. And then constructing a connection to a queue that is going to be deployed in a particular way. Okay, so we have account ID, and account ID would be referenced from the account. Okay, so the function itself, cool, really handy. And then the remaining is just us making a send message request to SQS, and then catching error if anything happens. And then after we're done with the try catch block, we're just sending it through to API gateway. So from the point of view of what we discussed in terms of synchronous is asynchronous communication, this function acts in a synchronous communication fashion. So it communicates with our sys clients through an API gateway. So we're waiting for some kind of response in the correct format. However, it also does a nice thing, which is sending our message to an SQS queue. So instead of calling another function that does the processing of our message, which is an anti-pattern actually, we are not we don't want to wait for that to happen. We want to have, I don't know, any available receiver of our information of our message to read the message and handle it as fast as it possible can. And that's why we're using SQS. And by the way, we don't want to have this message repeated, or in that case, received by multiple points, or like Lambda function or emails or SMS, etc., etc. So we don't want to spread the message. We just want to have that asynchronous communication, avoiding direct communication with our consumers. So we are establishing kind of a one-to-one relationship with an additional step in between being our SQS. Again, we don't want to send a message to multiple consumers at the same time. We don't want to notify a bunch of things, whatever that might be. That's why we're using SQS here. Okay, cool. So we are through with installation of the module, and let's have serverless deploy. Let me check. AWS profile this way, or was it? Let me just double check. Serverless. Serverless profile. Because I don't always remember the correct thing that I need to type there. Okay, so let's name agents. Not interesting. How do I? Oh yeah, that was the correct one. Profile and then temp user. Let's see what happens. So hopefully I'm going to create a bunch of resources, 2 functions, 1 queue, and 1 API gateway resource that's going to be covering all of our use cases. Okay, object containing for service properties not supported. Set service property directly with service name. What are you talking about? Okay, like this. Okay, maybe like so. Let's double check. How is it possible that they are not using the latest version of their own service? Come on. Okay, so while it's thinking, let's have a look at our receiver function. Okay, it's packaging. At least it was able to do something. SQS function and receiver function. So receiver function, again, we saw that from the SQL, so our serverless YAML file, that it was going to subscribe to some queue events, and that queue would be a receiver queue. It would be created again already, and we are waiting for an SQS event. So I'm assuming that the first thing that they do in the receiver function is waiting for the SQS event. Yep, with a specific format. We can even check that format. Let's see. Okay, SQS event. Let's go inside of the SQS event. We can see that directly at the top level of SQS event, we have records array, and each record consists of a bunch of things. And those records would be botched, bundled together messages that we're expecting. It would be either one message or a number of messages. And we're expecting then that message to contain the body, and a bunch of stuff that are useful to us. Okay, cool. We're going through a bunch of records just in case that we're batching it. Okay. We are gathering them and the messages attributes, I assume, or just extracting it. Okay. Cool, then outputting some stuff, and then, yeah, we're doing something. So essentially, this function does nothing more than just console logs stuff with a message body. So I assume if I send something in the body, it will be directly seeing in our logs. Okay, so let's check our CloudFormation for any changes. So I am in EU Central, just judging by the link. Okay. Cool. So judging by the link, I'm in the correct region. To my profile, I set up locally with the temp user's credentials that I change, let's say, every lecture. Let's go into stacks. Okay, so I'm not seeing anything, so I assume that might be somewhere in maybe US. Let's see what we have here. Does it say where we're actually building it? Temp user should be. Let's check what temp user is all about. So to check that, I want to cat the location of my root directory in AWS folder and config. Okay, there's a bunch of stuff. Okay, yeah, cool. I didn't need to do that even. So It's still in progress. Let's check what's inside. Hopefully I will see event stream to just double check what's getting it so long to create. Um, so events is streaming in. We have already an API gateway. We are waiting. Let's just double check if we're still waiting. Yeah, we're still waiting. Let's see what it says here. Okay, so it's updating a bunch of resources we already created. So we already have an API gateway. Let's go there just for us to make a request. Lambda rule is created in progress. Okay. A bunch of log groups created where we are going to see the output. So I assume, just judging by the code, that these console logs will be outputted into um, come on, create failed. Resource handler returned message upload file must be a non-empty zip. Okay, so this is just awkward. Well, in any case, I'm not going to try and change the examples that they have because it will probably take some time. It might have to do with, for example, a framework version. So let's go check we have the latest framework versions. Okay, so authentication, region, environment, it just looks the same. So um, SQS standard. What about our example with SNS? Let's just quickly check if it's still the same. Framework version, okay, stage, and resource handler return message. Okay, let's go and double check our events. It could have been rolled back already, but at least we're still able to see events in our confirmation. Upload file must be a non-empty zip. So probably issues with Webpack and zipping. And let's input AWS Lambda. Let's see what they say. Okay, so it might take us some time before we are able to decipher what exactly that means with an example. I'd say we leave it there and go to the next one. AWS Node text analysis. Because in other case, it just might be the empty one of the empty non-modules that we're just uploading there in S3 buckets, and it just takes time for us to go through. Since I wanted to analyze the next example, let's see. I assume I don't need to install anything. Let's check. Sentiment requires sentiment. Package JSON. Okay, let's quickly install that. And then serverless YAML file. Okay, so it seems like it has almost the same setup. We have an IRM rule that it is just allowing anything which is not fine. It adds a note true, okay, and it analyzes the note to some extent. Okay, so let's check those two functions. Add note is doing SNS publish, and analyze note is just, I assume, reading from the note. So let's see. As far as I remember, if I just put the publish method to our SNS thing, it could not. There is a possibility that the other function analyze node might not have enough permission to read from it. So let's just leave it like this, and hopefully it will be less painful to deploy it. Let's reuse the function that I already specified it there. So we are launching a serverless template. Okay, by now, since we are rolling back automatically with confirmation, I assume that that stack has already been rolled back. And let's see what we at the terminal. We're still packing it. Okay, so framework. Oh, I don't have a latest version. Oh, come on. What is my serverless version? Did not satisfy. Oh, it's less than. Okay, I have a latest, but it's not compatible with it. Okay. I hope that this would work. Otherwise, okay. Otherwise, that was the actual error that we encountered in the example here. It might be that serverless changed something inside and now it doesn't work with this code, doesn't work with the latest one. So hopefully my dignity is saved there. Let's just hope that this works. So yeah, going back to our stacks, I can see the update rollback completed. Hopefully all the functions have been deleted, all the resources have been deleted. Let's just double check. Create complete. We still have S3 buckets, and they're usually those that remain just because of S3 bucket policy of not deleting stuff that's kind of contains content. So let's quickly go there while it's still updating. Because the examples are fairly easy for this one, what we're doing here, yeah, as we're already seeing, two functions. One receives events from an HTTP. The other one listens to SNS events from the analyze node topic. Because of this setup, as with HTTP setup, they will be pre-created for us. So in this case, there would be an API gateway resource created for us. And in this case, there would be an SNS topic created for us. That is the same what happens to our serverless, just to make sure that everyone's on the same page. We're not specifying an API gateway here. We're only specifying the queue here, but the rest is created for us. So if I were to, yeah, deployment bucket, we're also not specifying all those log groups. Let me just double check if we see API gateway um, resource, yeah, created for us, and then we reference that API gateway back in our Lambda. So that's how it works. Okay, with that said, let's check what we uploaded to the bucket. It's not empty. Yep, it's still not empty. Dev. Okay, cool. And this is, okay, a bunch of stuff there. So we essentially uploaded um, this archive, which contains our Lambda functions, and then a bunch of templates, create an update stack. Okay, we just compile the template and serverless state uploaded there. Cool. So yeah, it seems to me that it's not empty. I don't know what happened there. Probably the version issue. Uh, I will try to run it and double check it once again. But yeah, as you can see, we were able to deploy at least the next example, this one. We already see that we have an endpoint that we can send notes to, and they will be, let's see, so analyze node would be console logging these two. Okay. With another stack created, let's check its resources. It should be less resources from what I can tell. Okay, well, okay, we're not using IAM rule, so that's fine. We have analyze log group, cool. That's exactly where we're going so that we are able to see the logs, these logs. So see whatever I send, it doesn't really matter in terms of the content. We probably have a negative note won't be published. What is the sentiment doing? Let's just double check. Analyze phrase. Okay, something really complex. We don't care that much about what it's doing. Let's just check the README to see if we're doing something. If we have some examples of what we can send. So we're sending, okay, an object. This is such a great day. Okay, so we're going to do exactly that. We don't even bother to open um, our postman. Let's just copy directly there. Want to create a post request with this. All I have to do is to input this value right here because that's how my API. Oh, stop it. That's how my API endpoint is different from their example. That's how all the API endpoints are different. So this is API gateway ID. Okay, come on. Well, this is just awkward. This and then copy. Come on. Do I have it? Yep. Cool. Some neat tricks. Jumping back and forth in the console as a real pro. Okay. Sending the request. Successfully added a note, and I assume that's coming from add note. And if that's coming from add note, we are past the validation, the basic validation that they had. We were able to construct a correct, or at least a correct-ish parameters for our SNS to publish. And yeah, with some um, old school callback HAL, we see that if that was a success, if the error object was not pre um, pre-populated, we're immediately going to the create response. We're creating a typical API gateway response with a message successfully added note. Let's check our Cloud Watch. We don't have anything here at the moment, but if I refresh, I assume a logwork would be created because we just triggered analyze node function. It was like the whole container spanned up. We were able to create another log group for that particular container. And this container has this ID. Let's see. So, and we have a positive node will be published because we send something like this. So positive note, this is such a great day. Okay, so this sentiment library just has a basic text analysis in terms of wording, I suppose that's used. And it gives us a score if we received something cool. So assume it was greater than 2, we received the console log. But in that case, the communication was not direct. The communication used an SNS topic. So instead of going from one lambda to another, so from lambda and node lambda function to analyze node lambda function, which again is an anti-pattern lambda triggering another lambda, we kind of want to have this fan out approach. And by fan out, I mean I want to potentially have an opportunity to um, analyze this node in other ways, not just give it a score. So analyze node and in this simple way. Maybe I want to have a more complex analyze tool. Maybe I want to resend that based on that node, send a bunch of emails, or if I want to have a SMS triggered. So with one event, I want to happen or notify a bunch of things, a bunch of listeners at the same time. This is a use case for SNS. We I assume that it was pre-created for us just because we inputted an event here, but let's just double check with our resources. If we see SNS topic, yep, we see that topic. Let's go inside, see how that looks like. And by the way, since we are inputting it um, as our destination, and we're saying that one lambda is listening to API gateway events, this is shown in the function overview. And from this function overview, I can even go to a particular NPI gateway endpoint because that's a trigger. That's how I know. Then let's see. I don't have any destinations because that's my custom code making stuff. We don't have like a direct connection in the code from analyze or add node function to the analyze node topic. But with analyze function, we have this connection established and we can see that this function is triggered by SNS. That's how I know this connection is there. So again, just to summarize, this function is doing something custom. AWS doesn't know about that. And it's sending requests to a particular SNS topic with a direct link. So that's why we don't see it in the console, but we are using topic array as our destination. And that topic would have a bunch of information. For example, one would be subscription, and by subscription I mean those bunch of or number of receivers or consumers of our SNS topic. Those people who want to be, or people or things or services that want to be notified when this topic receives an event. We don't have any filtering policy. So in terms of filtering, we don't specify anything like that. Well, let me just check. Yeah, it's in the subscriptions. Um, we don't have any filtering policy, so any event that happens to come to this topic would be sent to every um, to these subscriptions or this subscription in particular. Okay, and we have just one topic. Yep, analyze node topic, and that's exactly what we inputted in our serverless YAML file. So yep, that's it. Let's have a nice flow, which is serverless remove after we're done with our stuff. And that would go ahead and remove or trigger a stack delete process for us. Let's just make sure that we close everything here. And let's see if we see that update. Okay, come on. Okay, while it's thinking, okay, so it's removing objects. Let's see if that's triggering. Yeah, delete in progress. While it's thinking, since we've spent some time debugging um, our SQS topic, I assume that we can just go ahead and open another terminal to just quickly go through our second set of examples or second example with AWS OAuth 0 custom authorizer. Let's quickly go through um, this thing. Let me just go inside of the folder so I can trigger the deployment process while we talk through. Custom authorizer API. Okay, I'm here. Let's see. Yep. Then let's install stuff. Yeah, by the way, it should be nvm use the latest version because it was scoped to my terminal. Okay, so let's not do anything. Let's just bundle a bunch of commands. Once I install all the modules, I want to have serverless deploy or SLS deploy with AWS profile temp user. Okay, so while it's doing its thing, let's focus on the example at hand. Again, starting from a top level point, we have a bunch of stuff that we use. We are saying that this should be a service named AWS Custom Authorizer. So that would be exactly how our stack would be called. We're serverless offline, but that's not the point. This package just enables us to stream log back and forth and trigger functions without actually deploying them. Um, Then we have a provider, again, like a configuration stuff for our environment, for our stack and for our functions and resources. And we're saying that this should have an environment variable auth client ID and client 0, client public key, because I want to have this environment available in both of the functions. That's why I'm doing that. And not both, but in all the functions, because we have three functions. One function would be serving as that authorizer function with whatever logic that we can think of to authorize people. Okay, so let's see. What are you doing? OS_temp_dir is not a function. You kidding me? Come on. Let's see if they say anything in their README about that. So npm install, setup of 0, input those, serverless deploy. Okay, so that must be my version of Node. What do you have? Do you have anything useful in terms of the version? Let's see, version 12. Okay, let's quickly go and VM not list, install 12.1.0. Let's go with that. Okay, so let's get back to our examples. I want to have, okay, yeah. Oh, auth lambda is the one that is doing authorization with where it means it needs to. And then we have two public endpoints. I assume there would be HTTP based. So there'll be an API gateway created with these two functions belonging to that API gateway. One or maybe two different API gateways. API private, no, two different paths. One available publicly, so no authorization required to send events from that API gateway to Lambda, or to have any credentials to access our API gateway in the first place. And the second one is private. And as you can see, the only difference between these two is this line, and this line is notifying our serverless framework is that this function should be used as an authorizer. And the way it works is essentially, as you might know, any request that comes into this private endpoint, API private, would have to go through our function to, or requests would have to go through our function to justify some stuff that we have there inside of the function. And then if we're successfully through the function, only then the function handler private endpoint function would be triggered. Okay, so and there's a bunch of resources to handle responses from gateway, but that's just details. We don't need to talk about that at the moment. Okay, so let's see if I'm able to run SLS deploy with that. Let's hope. These people, come on. While we still have time, we can have a look at this function. As you can see, nothing special about this function. It's just a handler. Those handlers for private endpoint and public endpoint, they all three are, I assume, are stored in this file. Let's quickly collapse everything for us to have a look. So public endpoint, nothing more than just events and context headed, and it immediately returns something like a publicly available endpoint would. These headers are, of course, private endpoint on the other hand, as you can see, is doing the same thing. I would say that on the other hand was intentionally added there because lambdas and their like authentication has nothing to do with them, with the whole process. Um, so yeah, just have it in mind that you can offload anything regarding authentication to authorizer lambda and focus on your business logic in both of the public and private endpoints or private public lambdas. They don't have that kind of um, workload associated with them. We don't do any JWT checks. We don't check for any particular headers being available. That's already handled by API Gateway. Okay, so okay, let's see. Our authentication lambda, on the other hand, it receives the request from our authorizer. It's not an API gateway like a typical request. Um, in terms of it has a special format. Just be aware of that. Um, if that, in order for the whole thing to work, it needs to return a particular set of things. So let's just collapse everything. So as you can see, it's not if we're not throwing kind of any errors. So I'm not calling that callback that is passed automatically by API Gateway again, where we have that um, rejection of authentication or authorization defined for us in a standardized way. If we're not calling it, everything is fine. So as you can see, um, let's open up the try catch. Um, so we are generating the policy with the correct one so that the whole thing work with a callback. And oh, assume that, okay, that's not the case. Apologies. Yet these are the policy, the authentication response. Okay, yeah, cool, cool. Because I was a bit confused in terms of like, uh, did they define something or did they use any package? Because yeah, I don't see any. Cool. So that callback is nothing more than just like old-fashioned way of like handling asynchronous stuff. So if the first one is an error, regardless of what it is, it's just how we handle asynchronous stuff, old-fashioned way for those of you young kids. Um, but in the case of the success, we need to return a specific response, just as we usually do with API Gateway. So in terms of API Gateway, nothing has changed. Where the throw-in error, so this is equivalent to async await throw error, or like in try catch throw error, for example, if we receive any. Um, and this is the exact policy. And so if you take a look at the policy itself, it's a specific document, or specific, I would say, yeah, object that we need to send back. It needs to have the principal ID in terms of who's sending that. And that principal ID um, is stored in our JWT, for example. So a bunch of stuff. The most important is method ARIAN. Because that's the resource that it was asking for authentication. So it's all publicly available in the docs. The most important one was this, yeah, action part, effect and resource. So essentially, it's sort of like as if we were saying, okay, it was deployed. Thank God. As if we were saying, or if we're constructing an actual RAM or IAM rule, and we wanted to provide that IAM field raw. If you're not using any packages or plugins that do that for you, this is exactly how you do that. So if you spend enough time seeing or looking at this document, you would realize that you're actually building the policy that would specify that this resource that was making a request was authorized to access Lambda, and that Lambda was our a private endpoint handler. And yep, let's go back. So yeah, there are many other cases where we can use a less strict approach in terms of authorization. Here is we are actually storing our authentication information in a separate place, the auth 0, in a more or less strict fashion. We may just return true or false in some cases and map that true or false to a particular already defined managed policy to allow or forbid access to a resource. The case of authentication or custom authorizers um, remains the same on a high level. You need to say that whether you authorize that or not, and you say that by the returning a correct format for API gateway to handle, or just throwing an error, or essentially not returning a correct format, and that would be considered by API gateway as a service, as a false, or as a failed authentication slash authorization. The rest is not important for us at the moment. If you're interested in how Auth0 works, you can have a look on their website. But yeah, let's go ahead and see what we have in terms of stacks. So it was deployed in a different region, I assume. Again, US West 2. Why? So arbitrary. That region was probably, yeah, it was probably in serverless YAML. So, and that preceded my own configuration in my profile. That's fine. There's one stack, custom authorizer. Let's have a look. We should see at least three functions, or at least we'll expect to see three functions that do that. And we are interested in one of the functions for private, the logs of one of the functions. So this auth log function, and we are interested in private endpoint logs log group. Okay, cool. Let's go into logs because this is how you are probably going to debug the most stuff if you have the production experience, or when you have a production experience. And also let's go into public log group. I saw you. Come on. Auth log group, private. Okay, you know what? Let's just go to public endpoint Lambda function. If I don't see it from the stack, I am sure to be able to access it um, from the console. Okay, it gracefully takes some time to allow me to see the insights. I go to monitor and I click view in CloudWatch. If you just stop jumping around, please. Okay, cool. Yeah, as expected, API gateway is used as a trigger for our function. So, how do they access API gateway? By the way, a really nice example of what we're doing with custom authorizers would be if we were to go to the actual API gateway REST API. So it is REST API type of gateway. So HTTP API in our events would be considered as HTTP API. Okay, makes sense, but still confusing. So if we go to the private, um, we can see that it says that it has a private authorization in front of it. For public, we don't see that. So no authorization required. Um, a funny thing is, if we were to make a test request, so it's a public, no, I don't want to put anything, request body, it's just to make it, I don't know, tests. Let's see what happens. Hi from public API with post request, cool. Responded with some specific headers. Um, and yeah, we received all the information there. Funny thing is, if we do try to do that with private API, private lambda, tests, and then tests, as you can see, we're still seeing the same response, but and that might be for some a bit confusing because we're kind of saying that, hey, private endpoint is already private because it has private authorization. When doing that from an API gateway perspective or API gateway console, what you did was already passed the authorization point. So you inputted your credentials, you passed the authorization point. That's why API Gateway is not triggering your authorization. If we were to, let me see. So yeah, in this whole process, when I'm testing it, this picture shows exactly what happens. I am testing and going to directly Lambda custom authorizer or in going through formatting the request. We don't see any authorization per se right here. So if I don't want to open this, I want to probably make or try to make the same request that I did last time with curl. And this time I want to trigger different API. Yeah, let's copy the whole thing. And we might I might want to change stuff. So we don't need to do anything about the data. As you saw, it just responds with something. What I wanted to do just to post at least something to our public endpoint and we receive the message. So as expected, public endpoint doesn't have anything in front of it. Whereas in the private case, if I were to change it to private, and still having the same API gateway there, I will receive unauthorized just because now I am behind this authorization thing and I'm not allowed to do that. Let's check README to see what the whole thing is requiring us to do in order to successfully call that thing. So custom authorized function is passed event object as follows. Authorization, okay. Um, yeah, we would need to go a bit more into depth in terms of how much information auth0 needs to have. I already pre-created the public key and its secrets with my auth0 client ID and public key information generated from auth0, and that should be enough for me to actually make requests. But yeah, I don't want to spend more time on that. So this was two demos of how to work with both SQS and SNS and with custom authorization. So once you get the overall idea of how those services work, you realize that they are not that complicated. One just being a bunch of different types of queuing services like SNS and SQS with different purposes and different destinations. The other is nothing more than just plain old AWS Lambda function that just stands in front of your protected API gateway endpoints and tries to say yes or no, true or false in a correct format that API gateway is actually expecting us. And that's it. Hopefully that was um, helpful to some of you. Um, if you have any questions, be sure to reach out in Discord, or come to the next Q&A session. We still have two modules to go at least. One with containerization and uh, the last one with BFF focus. They both focus on Docker as the medium or as the main hands-on experience that you're going to be doing, and they're both using AWS Elastic Beanstalk, a platform as a service solution that AWS provides developers with in order for them to have easy time deploying code, managing different environments, deleting and recreating stacks as we do manually in our console. So really nice thing in general. So yep, thank you for your attention. Um, See you next time. And again, be sure to reach